Alright, so this is 4.4. Today we're solving quadratic equations using the quadratic formula. So we've done it by factoring and we've done it by completing the square. And now we're going to use the actual quadratic formula and see which method we like best. I'm going to breeze through the warm-up here pretty quickly. So try to follow along. If you need to pause and rewind and watch another section again, you can go ahead and do that. So we're moving the 144 over to the other side by adding it to both sides, and we get x squared equals 144. Then we take the square root of both sides, and we get x equals plus or minus 12. Make sure you include the plus or minus, because plus 12 times plus 12 is 144, and minus 12 times minus 12 is 144. And these represent two distinct solutions. So those are your two roots. Here, you can do your sum and product factoring if you want, or you could complete the square and make it a little trickier on yourself if you want to do that way. But here the factors for negative 6, we're looking at negative 6 and 1, negative 1 and 6, negative 2 and 3, and negative 3 and 2. And of course this is the one that has a difference of negative 5, so we go x minus 6 times x plus 1 equals 0. And then of course x equals 6 and x equals negative 1. And those are your two distinct solutions for that one. Alright, so the next two. X minus 3 squared minus 45. So I'm going to bump that 45 over to the other side. Right, this is x minus 3 all squared equals 45. Now we want to get the x alone, but it's tied to this negative 3, which they're both tied to this squared. So we take the square root of the whole thing, and we get x minus 3 equals plus or minus root 45. Now, root 45 can be written as the root of 9 times 5. 5 is prime, but 9 is not. 9 is a perfect square. You can take the square root of 9, and it's 3. So the 3 can come outside the root sign, and root 45 can be written as 3 root 5. So now we're going to add 3 to both sides, and we get x equals 3 plus or minus 3 root 5. And again, this represents two distinct solutions. One of them is 3 plus 3 root 5, and the other solution is 3 minus 3 root 5. Okay, so let's take a look at this one. Now, normally we'd want to factor this 2 out, but we can't because 7 doesn't divide by 2 and 1 doesn't either, so it would give us something really ugly. So we could use one of two methods here. 2 times 1 is 2, and you could come up with the factors of that, which are 2 and 1, and that's basically it. And then we have no way for these things to add up to plus 7x when we multiply them. So here, this is a good indicator that we are going to need to try to factor this in a different way, or complete the square in this case. So we will pull out that 2. Right, this is x squared plus 7 halves x plus 1 half. And that's all equal to 0. That 2 can just disappear because of the 0 on this side. And then we're going to try to complete the square here. So we take half of this term, which is 7 over 4, and we square it, which is 49 over 16. So we go x squared plus 7 halves x plus 49 over 16 minus 49 over 16 plus a half equals 0. This we turn into a binomial, which will be x plus this one, 7 over 4 all squared. And then 49, negative 49 over 16 plus 1/2. 1/2 is 8 over 16. So negative 49 plus 8 is negative 41 over 16 equals 0. So x plus 7 over 4 all squared equals 41 over 16. Now we're going to take the square root of both sides, and we have x plus 7/4 on the left and root 41. This will be plus or minus root 41 over 4 on the right. So now we subtract 7/4, and of course 41 is a prime number, so we're not going to be able to reduce this root whatsoever. So then we can rewrite this thing just as negative 7 plus or minus root 41 all over 4, because the 7 was over 4 and the root 41 was also over 4. And this represents two distinct solutions again. The one that is negative 7 plus root 41 over 4 and negative 7 minus root 41 over 4. So those are your two distinct solutions. And here, that was a lot of work and a lot of ugly numbers and a lot of trouble. So there's got to be a better way, and you've heard it before, and we're going to review it again today. There is a better way, and it's the quadratic formula. So hooray. Hooray! So let's get to work using this quadratic formula. It says, use the steps of completing the square and the square root properties to solve the general quadratic equation. Okay, this is going to be ugly, bear with me. I want to take out a factor of a. And that leaves us with x squared here, and b over a, x, here, plus c over a, here, equals 0. Now that a disappears, these other a's will have to stay. Now we're going to divide this by 2. So we get b over 2a, and then we're going to square it, and we get b squared over 4a squared. Just like we do with our linear term when we use real numbers. Okay? So let's see what this looks like. So then we get x squared plus b over 2a was half the linear term. So b over 2a. And then plus b squared over 4a squared minus b squared over 4a squared plus c over a equals 0. Okay, now this is pretty cumbersome and kind of nasty, but this we can turn into a perfect, or a binomial, and square it, and then these we can try to combine in some way if we can. So this becomes x plus, oh sorry, this wasn't b over 2a, this was b over a. Now it becomes b over 2a all squared, and then on the other side we have b squared over 4a squared, because I just moved this over and changed the sign, and then minus c over a. Now we're going to take the square root of both sides. So we go root, and we go root to this whole thing. And I'm going to need to bump this thing down and give myself more space. Let's see if we end up with the right stuff here. So x plus b over 2a equals, okay, now let's remember that when we take the square root of this thing, we're going to get the plus and minus version. And now we have this equals plus or minus square root b squared over 4a squared minus c over a. This whole thing is rooted. Alright, now let's get that b over 2a to the other side by subtracting. So x equals negative b over 2a plus or minus the square root of all this stuff, c over a. Alright, now we want to find a common denominator here, or we want to find some way basically to put these things together, which will be a common denominator. So the common denominator is 2a. So we're going to multiply this whole thing by 2a over 2a. So we go 2a over 2a. Now, what that will look like is negative b plus or minus, and when we move this top 2a in, when you move it under the radical sign, it becomes 4a squared. Because to bring it out, you'd square root it, and it has to end up as 2a when you square root it. So when you put it in, it has to be squared. So it goes in as a 4a. So it will go 4a b squared, and of course this is under the roots, over 4a squared. Sorry, 4a squared b squared over 4a squared minus 4a squared c over a. And then of course, I've run us out of space again. And then we have to recall that this whole thing was written over 2a. That was the common denominator that we found here. Alright, so in this case, the 4a squareds cancel off, numerator, denominator, and one of the a's will cancel off with the denominator a, and all we're left with here is x equals negative b plus or minus, and then the square root of all that's left here is a b squared, and then all that's left here is minus 4 times a times c. And thus we have derived, all over 2a, we have successfully derived the known version of the quadratic formula. Summary: the roots of any quadratic equation can be determined using the quadratic formula, which I'm not going to bother rewriting. I'm just going to show you it again here in the box. There's your quadratic formula. And if you remember the song that I sang for you last semester in Foundations 20, that's a bonus. Alright, so use the quadratic formula to solve each of the following quadratic equations. Confirm with the TI-82, that's just a Texas Instruments calculator. You can just use Desmos online, or just whatever you want to do. So let's check this. Now, we can look at this thing, and you could try to do the sum and product method, and it will work. So that's the method we'll use to verify that we're right. So negative 12, the products could be negative 6 and 2, and of course those will give you the successful sum and product factors. So x minus 6 times x plus 2 equals 0. And we're going to find out that our roots are positive 6 and negative 2. But we're going to use the quadratic formula just to prove that it works. So x equals negative b. So a is always the coefficient in front of the x squared, b is the coefficient in front of the x, and c is always the constant. So a here is just 1. It's not 0, otherwise there would be no x squared whatsoever. So it's 1. So x equals negative b. Now that's the negative of negative 4, which is positive 4, plus or minus square root. B squared would be 4 squared is 16, minus 4 times a, which is 1, times c, which is negative 12, all over 2a. So let's simplify this a little more. 4 plus or minus square root. And in the square root we have 16 and then a minus a negative, so that's 16 plus, and 4 times 12 is 48, all over 2a. So x equals 4 plus or minus square root. 16 plus 48 is 64, and this is all going to be over 2a. X equals 4 plus or minus, and the square root of 64 is 8, all over 2a, and I'm sorry, a is just 1, so this is all over 2, and we don't need to keep putting the a down. So then we get two distinct solutions, 4 plus 8 over 2 and 4 minus 8 over 2. So 4 plus 8 is 12 over 2, which is 6, and 4 minus 8 is negative 4 over 2, which is negative 2. And of course, we predicted this right from the start, and we were right, because we're awesome. So let's do it again with the next one. Clear my space a little bit here, because these ones are quite space filling. So very quickly move your 25 over to the other side by subtracting. So x squared plus 10x minus 25 equals 0. They always have to be all on the same side in order for you to get the proper signs and set equal to 0 for you to use the quadratic formula. So x equals negative b, so that would be negative 10 plus or minus square root. B squared is 10 squared, which is 100, minus 4 times a is 1, times c, which is minus 25, and all over 2a, and again a is 1, so we just write over 2. And now we can start simplifying. So within the brackets here, negative 4 times negative 25 is positive 100, so we have the root of 100 plus 100, all over 2. So x equals negative 10 plus or minus root 200, all divided by 2, and x equals, now negative 10 divided by 2 is negative 5, okay, and then root 200 is the root of 100 times 2, and 100 has a perfect root and it's 10. 2 is prime, so we have to leave it under here, so this can be written as 10 root 2. So we go plus or minus 10 root 2, and this one is still over 2 because we only divided this one off so far. We haven't divided this one by 2 yet. But now we can, and these can represent two distinct solutions by writing this as x equals negative 5 plus or minus, and 10 divided by 2 is 5 root 2, and you're done. Okay? We would never have been able to find these by doing sum and product because we just don't test roots. So I want you to take the time and do these next two on your own using your quadratic formula and see how you do, and then once you're done, move on to the next page. Alright, so right here, when using the quadratic formula, you can tell how many roots you will have and what their nature is by examining the part under the root sign. This is referred to as the discriminant. When the value of the discriminant is positive, there are blank, distinct, and equal real roots. That would be 2. When the value of the discriminant is 0, there is 1 distinct real root, or perhaps 0, we'll have to double check that because I don't have my textbook with me right now. When the value of the discriminant is negative, there are no real roots. There you go. Okay. Here's your turn. Use the discriminant to determine the nature of the roots for each quadratic equation checked by graphing. So all we have to worry about is this part, b squared minus 4ac, and figure out what's going on. So b squared is 25 minus 4ac. A is 1 and c is 4. So that's 1 times 4. And this will be 25 minus 16. And this is a positive number, and it's positive 9. So there will be two distinct and real roots because we can take the root of positive 9. So that's good. This one, b squared is 4 squared, which is 16, minus 4ac. A is 3, so 4 times 3. And c is 4/3. Okay? Now, 3 times 4/3, your 3's will cancel, and we get 16 minus 4 times 4, which is 16. And here you go, and your discriminant is 0, meaning you will only have one root. And you can double check by graphing this. 2 roots. 2 roots. Okay, that should be a lowercase r. Alright, now this one, again, make sure you have everything on the same side of the equals sign. So move that 9 over and flip the sign. And then test your discriminant again. B squared is negative 8 squared, which is 64, minus 4ac. A is 2. C is 9. So this is 64 minus. Now, 4 times 9 is 36. 36 times 2 is 72. Now here we have 64 minus 72, which gives us a negative number. And since it's the negative, and the b squared minus 4ac is what's underneath the root sign, we're trying to take the root of a negative, and we can't take the root of a negative. So there are no real roots in this case. All right. And I think we're going to skip this one for now and call it quits for today. You can go ahead and try it on your own if you want to get practice. But that's it for today. I'll see you in class tomorrow.